Hi everyone, today we're going to talk about how to graph polar coordinates. This is going to be a short one. I'm just going to introduce you to the polar coordinate system and how to go about graphing points in that system. So we're going to start off then. What is the polar coordinate system? So the polar coordinate system, you're very familiar with plotting with a rectangular coordinate system. So this is what most people learn in Algebra 1, and they stick with this rectangular coordinate system all the way up through Algebra 2 and into pre-calculus. And the rectangular coordinate system is the common coordinate grid where you're given an x and you're given a y, and you go about plotting them. Today, however, we're going to look at a new coordinate system that's called the polar coordinate system. And you can see it is markedly different from the rectangular system. The center of the graph in a polar coordinate system is called the pole. In the xy, in the rectangular, we call it the origin. We call it the pole for a polar system. And there it is. Angles are measured from the positive x-axis, which is right there. Points are represented by two things. They're represented by a radius and an angle. So an r, radius goes first, and then the angle, which is theta. Radius, angle, right? Kind of makes sense. To plot the point 5 comma pi over 4, first you're going to find the angle. Now, in the polar coordinate system, sometimes the angles are given in radians, the way this is, and sometimes they're given in degrees. You need to be comfortable going back and forth between the two different forms, either radians or degrees. In pi over 4, if we want to find that angle, you would start on the positive x-axis, and you would always rotate in a counterclockwise direction, so going up from the positive x-axis, and you would go up pi over 4 degrees. There it is. Then you would move out along that side, that terminal side, which is the blue side, you would move out 5 steps. 1, 2, 3, 4, 5. And that's your dot. There it is. That's all there is to it. That's how you plot a point in the polar coordinate system. First you go the angle, and then you go out however that far. A negative angle would just go in the opposite direction. It would be measured clockwise. So for example, 3 comma negative 3 pi over 4, we would start on that positive axis, and we would go in the negative direction 3 pi over 4 units, or angle measurements. And then we would count out 3 spaces, 1, 2, 3, and we would put the dot. And there it is. All right, so positives go up from the positive and negatives go down from the negative. To plot a point with a negative radius, this is where it gets a little tiny bit trickier. First, you would find the terminal side of the angle, but then you would measure the pole in the negative direction. Let me show you what I mean. Negative 4 comma 2 pi over 3. Remember, the first step is always to find the angle. So since the angle is positive, we would go up 2 pi over 3. And there's the line. Now, since the radius is negative, you're going to imagine going backwards 4 steps and put the dot there. All right, so let's plot a few points. 7 comma pi over 2. So first we find the angle, pi over 2, and then we go up 7 dots, 7 points. There it is. What about negative 7, negative pi over 2? So negative pi over 2 would go in the opposite direction, so it would go in the negative direction, down. There's the terminal angle, but this time negative 7, which means we want to go backwards, which is going to be on the same point here, right? If we are going in that negative direction, there it is, and we go backwards, 1, 2, 3, 4, 5, 6, 7, we wind up on that same dot. Okay, what about 7 comma 5 pi over 2? 5 pi over 2 goes all the way around, right? Starts here, goes pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, which lines up being the exact same line. And if we go out 7, we're still on that same dot. And what about 7 comma negative 3 pi over 2? So negative 3 pi over 2 would be that way. Still the same line, and this time we go up 7, and we're on that same dot. Notice all 4 of these points wind up in the same space. So that's different. In the rectangular coordinate system, you can't do that. But in the polar coordinate system, every point has a lot of different ways to get there, right? I always think of, you think about that point and your goal is to try and get to that point. Well, how can we do that? There's lots of ways to get to that point. We can go this direction and go forward. We can go this direction and go backwards. We can go this direction all the way around. Lots of different ways to do that. Right? You can also do this in degrees. So here we have a polar coordinate grid system that is given in degrees, and it's going to be the exact same manner. 8, 210 would be right there. So we would start at 0, go all the way around at 210, and then go forward 1, 2, 3, 4, 5, 6, 7, 8. 6, negative 120. So we would start at 0 to negative 120. So we're going to go around this direction, which would be right there, and then go backwards. Nope, not go backwards, sorry. Negative 120 there, and then go forward 6. 1, 2, 3, 4, 5, 6. There it is. Negative 5, 300. So we would start at 0, we'd go 300, which is this line right here, and then go backwards 1, 2, 3, 4, 5, and it should be right there. And then one more, 540, negative 3. So if we start at 0 and we go 360 all the way around, and then another 90, now we're at 450, and then another 90, and now we're at 540. So we're on this line, and it's a negative 3, so we're going to go backwards 1, 2, 3. And there it is. All right, so now you know how to graph things in the polar coordinate system. So I gave you a worksheet in OneNote, and I'd like for you to do it. Intro to Polar Coordinates. All it is graphing, and tomorrow in class, we'll check and see how you did. Good luck.